Right. Questions related to linear expansion, right? Okay. Today, this one is the question arrangement for the linear expansion with the fractional change of area, volume, and length, right? Okay. Question number 375. The fractional error of a rod of length 2 meter made of a material A when the temperature is increased by 50 degrees Celsius is equal to that when a rod of length 1 meter made of a material B is increased by 100 degrees Celsius, then the ratio of linear expansivity of A and linear expansivity of B. First of all, we should identify fractional change of length, right? Fractional change of length is basic equation L2 minus L1 L2 minus L1 equal L1 alpha theta 2 minus theta 1. Fractional change of length L2 minus L1 over L1 equals alpha delta theta. This could be the equation, right? 375. Okay. Then you are given temperature increasement 54A of the length 2 meter. पुते में fractional error or fractional change of length. Fractional error or fractional change of length doesn't depend on the initial length, right? Fractional change of length of the rod of 2 meter and fractional change of length of the rod of 1 meter. Fraction doesn't depend on the majority part of the initial length, as it is mentioned as ratio, right? Okay. They need this whole value. This whole value depending only on these two. That then, according to the question, material B and material A equal, no? Which means alpha A into delta theta, 50 degrees Celsius, similar to alpha B into 100 degree increasement of the temperature. So alpha A over alpha B should be 2 by 1. It's 2. Then correct answer is second one. Answer is second one. Okay. 376. The variation of fractional error of rod X with the increase in temperature delta beta is shown in the graph. The variation of fractional error of rod L2 minus L1 equal L1 alpha theta 2 minus theta 1. Fractional change L2 minus L1 over L1. Change of length is the fractional basic error occurred by the reading divided by L1, then equals to alpha delta theta, right? Then this one seems as y-axis, this one gradient, this one x-axis. It could be straight line passing through the origin, right? Straight line passing through the origin. Delta theta vary like that. Answer A. First one is the correct answer, right? Okay. Answer is A. Okay. Let's take question number from 377, right? 377, right. The variation of temperature increasement, delta theta. Variation of temperature increasement of delta theta with the fractional increasement in the length of the two materials A and B are as shown in the figure. The respective linear expansivities may be. Then shape of the graph, well identified one. No? Shape of the graph, well identified one. Its x is fractional change, temperature difference theta. Then gradient of the corresponding graph, 377. Tan theta gradient is linear expansivity, right? L2 minus L1 over L1 equal L1 delta theta, such as y equal mx, right? Yes. Then gradient should be linear expansivity. Then gradient of A tan theta for A, we can say 13 to 10 to the power minus 6 unit may be standard unit divided by 20. It's like this, no? Okay, then it should be 0, 0 cancel, 1.5 10 to the power minus 6 per degree Celsius. That's the gradient. Then for A, we have two answers, first and foremost. And for B, we have the gradient tan theta. For B, gradient is 20 into 10 to the power minus 6 over 30. It's 2, 3, 10 to the power minus 6 per degree Celsius. So, correct answer is first one, right? Answer is first one. Okay. Copy the answer. Question number 378. If the fractional increase in length of a copper rod when the temperature is increased by 90 degrees X, fractional increase of length, this one, no? Fractional increase of length of the copper rod. We don't have this alpha, right? Okay. Fractional change of length is alpha delta theta. It could be X, no? It's 378. Fractional change of length X is alpha A, first material, into 90. And for copper, first one is, it's copper, no? A is copper. Then the other one, fractional increasing area of copper, fractional change of area. Then we have A2 minus A1 equal A1 beta theta, theta temperature difference. Fractional change of area over A1 equal beta theta, right? Fractional change of area is this one. It is written as beta theta. We can say it's y equal twice of alpha copper A into temperature difference is 45. And third case, fractional increase in volume when the temperature of copper sphere is increased to 30 degrees Celsius. Then volume expansion V2 minus V1 equal V1 gamma theta, theta temperature difference here, right? Okay, then we have V2 minus V1 over V1 equal gamma theta. Gamma equals to 3 alpha. Then you can say that could be Z, no? Z equal 3 alpha A into 30. Now you are asked to identify the correct arrangement, no? They need the combination X, Y, Z. We should combine, no? X, Y, Z, we should combine, no? So we can see, we can divide first and second equations, right? We can divide first and second equation, first one divided by second one. X over Y equal alpha E 90 over 2 alpha E into 45. 2 into 45, 90, 90, 90 cancel. Then these two equal, then X is Y, no? This is first identification. Second identification, X1, Y getting equal, no? Then we are considering these two. We have Y into Y divided by Z is 2 alpha A 45 over 3 alpha A 30, right? 3 times of 3. 3 times of 30 is 90. 90, 90 cancel. Again, this side cancel. It's Y equals Z. So you can say X equal Y equal Z, right? This could be the correct answer. Right. Can we complete? Correct answer is first one, right? Okay. No need to simplify more, Budhe. After writing this one, you can see product of this and this getting same, no? Why? Here product is 90. Here product is 90 alpha. Here product is 90 alpha B, alpha A. Here product is 90 alpha, no? Then getting equal, XY equal, then no need to divide like this, right? Right. Then question number 379. 379. The fractional increasing area of metal sheet, when the temperature is increased by 50 degrees Celsius is 6 into 10 to the power 5. Fractional change of area, this one, no? This is 6 into 10 to the power minus 5 equal, they need linear expansivity, no? It's 2 alpha theta 50 degrees Celsius. Right, that's it. Then alpha becomes, devarak methadin value no 52 CI. It should be 6 into 10 to the power 100 divided by 10 to the power minus 6, no? Temperature is increased by 50 degrees Celsius. So it becomes 6 into 10 to the power minus 5 divided by 100, right? It should be 6 into 10 to the power minus 7 per degree Celsius. Done. Correct answer according to the answers, fourth one, right? Fourth one is the correct answer. Answer 4. Okay, right, done. Can we check 380? When the temperature increase of a certain rod is 100 degrees Celsius, its fractional increase in length is S. Temperature 100 degrees Celsius, fractional increase of length. Fractional increase of length. Is S, right? Okay, when the temperature is 50. Fractional change of length, we can say L2 minus L1 over L1 equal alpha delta theta, right? This is S. S equals let it alpha temperature 100. First one. Second one, that of the temperature increasement is 50 degrees Celsius is S1. S1 is alpha into 50. This is second one. And when the temperature of metallic sheet made of a same material is 100 degrees Celsius, its fractional increasement when the temperature of a metallic sheet made of the same material, the fractional change of area is S2. S2 becomes 2 alpha into 100 degrees Celsius. This is third one. Okay. So, they need the fractional increase of area is S2. They need the combination, no? S1 with S and S2 with S combination. Then considering first and second, we can say here this one is 50 alpha, here 100 alpha, no? S over S1 equal 100 alpha over 50 alpha. Here 1, here 2, S equal 2S1. First thing. Second thing, first and third equations combine with each other. So we have S over S2 equal here 100 alpha and here 200 alpha. 100 alpha over 200 alpha. It's 1, 2 here. It's S becomes S2 by 2, no? What is the combination? S1 equals S. S equal to S1. First answer. 2S1 equals S. And here 2S equal S2, no? This should be the correct answer, right? Mark the correct answer. Okay, 381. Next. 381. Right. 381. The initial length, linear expansivity and increasement in the temperature by 5 metals are shown. Initial length, linear expansivity and increasement of temperature mentioned, now shown in the figure. From the sheet, from these select the metal with highest fractional increase in length. The fractional increasement does depend only on the linear expansivity and temperature difference, right? Like this. It's 381. 381. L2 minus L1 over L1 equal alpha delta theta. සාමාන්‍යයෙන් exams වලට ඔය fractional change of length කියන එක හරි අඩුවෙන් focus වෙලා තියෙන්නේ. ඒකයි අර එකකට එකක් වෙනස් මට්ටමේ එකම formula set වෙන විදිහට ගණන් කීපයක් හදලා දාලා තියෙන්නේ. හරි? Right. Accuracy we have to manage. Then you can see fractional increasement of length decided by product of these two. Now you have to consider product of each material A, B, C without considering the initial. Initial length is not affected. Then C, linear expansivity highest one. According to the answers we have, වැඩි කරලම දාගෙන ගියත් කමන්නේ නේද? We can see first one. එතන 12 වරක් 2 24යි. මෙතන 8 වරක් 4 32යි 320ක් වෙනවා නේද? මෙතන 240යි. 20 into 10, 200. Here, 13 to 15, 450. And last one, 12 into 4, 480. වැඩිම එක්කෙනා තියෙන පස්වෙනි එකේ නේ. Linear expansivity 12, but temperature 40, no? 12 into 4, 400, yes, 418 to 10 to the power minus 6 could be the final answer. Then, highest fractional increasement of the length is decided by 5, fifth answer, right? Can we manage the correct answer? Okay, right. Okay, number 382. When the temperature of metal sphere is increased by 100 degrees Celsius, fractional increase of length is 0.0012. The linear expansivity of the sphere is, when the temperature of metal sphere is increased by 100 degrees Celsius, fractional increase of length is given. No? Fractional increase of length mentioned here. This one is 0.0012. This one 0.0012 equal alpha to be found theta 100 degrees Celsius. We have to add two zeros here, no? 0.000012 per degree Celsius. This could be the answer. Answer best one is first one, no? First one is the correct answer. Right. 283, 382. The variation of temperature increase one delta theta with the length L. With the length L for two rods made of the material A and B shown in the graph. The ratio of the fractional increase in A when the temperature is increased by 30 degrees Celsius. Fractional increase of A for 30 degrees Celsius divided by fractional increase of B when the temperature 60 degrees Celsius. Same equation. So 380. Right. Fractional increase of A, alpha A delta theta divided by alpha B delta theta, right? Alpha A delta theta decided by, then we have to take the gradient of each graph, no? Can we consider the gradient of each graph? Then tan theta A represents alpha A. We can say that value 0.0028 minus 0.0020, no? 0.0020 divided by tan theta A, 0.0028 minus 0.0020 divided by corresponding length is 40 degrees Celsius. This is tan theta A. It's alpha A. Alpha A becomes 0.0020 divided by 40. No? It becomes here 0.5 into 10 to the power 1, 2, 3, 4, 5 minus 5 per degree Celsius. It's next tan theta B becomes tan theta B, second material, next one. The gradient we can say 0.0026. 0026 minus 0.0024, no? 0.0024 divided by 30 degrees Celsius. Here we have 0.0002 divided by 30 now. It's 2 by 3 into 10 to the power 1, 2, 3, 4, 5, no? Minus 5 per degree Celsius. Now we have to consider alpha A delta theta divided by alpha B delta theta. Can I have the values? Alpha A 0.5, 10 to the power minus 5, temperature difference. Multiple by increase of temperature for material A is 30, divided by this one, 2, 3, 10 to the power minus 5 per degree Celsius, multiple by 16. Right, done. This should be the product, no? Here we have 1, here 2. So it becomes 2 into 2, 4, 3 goes up, no? It's 1.5 over 4 into 10 to the power minus 5 over 10 to the power minus 5. These two cancel. Then it should be 1.5 over 4, no? Yes. (0.375). Right. Complete the final answer. But here we have a mistake, no? 0.0028 minus 0.0020, 0.008, right? Yes. Then this should be 1, 2, 3, 4, 5. It's 2 into 10 to the power minus 5, no? Right. Here, this should be 2. Yes, then 2, 1, 2 cancel. This becomes up, no? 3 by 2. It's 3 by 2 should be the final answer. 1.5 like this. Right, next one. We have to consider two structured essay applications related to observation of the given object through a lens, a prism, and vertical pendulum process, no? Oscillation of pendulum, right? Can we start practical number H? Observing the deviation of ray through the prism and obtaining the minimum deviation angle. Then we can discuss that one through the question, right? Okay, 384. Can we consider? Okay. Consider initial part. Consider that you are supplied with an equilateral glass prism, underline equilateral glass prism, drawing board, drawing pins, 4 optical pins, few white sheets of paper, a ruler and protractor. Consider that using the given materials, you have to find angle of deviation by obtaining the emergent ray for few rays incident on the surface of the prism. Right. Basically, Buddha, we have two experiments related to prism. Right. Most of them, basically, we are using the critical angle method to find the refractive index. Exam එකට ගොඩක් focus වෙලා තියෙන්නේ ඕක. But measuring the deviation angle අපිට හුඟක් වෙලාවට විභාගෙට focus වෙන්නේ through spectrometer. ඒ කියන්නේ pins ගහලා කරන experiment එකක් විදිහට තාම මේක exam එකට focus වෙලා නැහැ. අපි පොඩ්ඩක් බලමු කොහොමද manage වෙන්නේ කියලා. Consider the incident angle starting from 30 degree, gradually increasing up to 67 on PQ surface of the prism as marked on the diagram, where the borders of the prism are marked on using the protractor. Okay. We have the diagram, no? Okay. After that, the light ray which the prism placed on the white sheet of the paper on the borders mark on it is shown in the diagram given below. Consider one incident angle of I1. Okay, I1 is this one, right? It is properly drawn here. Okay. Briefly state the way in which you obtain the incident angle in that instant. The two optical pin used for P1 and P2, right? We have to keep first pin, right? Just away from the surface of PQ, and the other one right here. These two we can say P1 and P2, right? Path of the light ray we can draw by using the figure like this. Light ray goes like this, no? Here we have normal, and the light ray emerge to here, no? Okay, this is the way of the light ray. And we have to put another two pins, P3 and P4, align with each other while looking through this side, no? Surface of PQ. So this is I1, here R1, here R2, and here I2. Now we have to tabulate I1 and I2. Now, when we are going to find the deviation angle, this could be the original path of the light ray with the broken lines. This is the new path of the light ray. So here we have deviation angle. This is angle of deviation, isn't it, Buddha? Yeah. Then you can find, after the construction, first of all, we have to put P1, P2, align with each other while looking through this side. And after that, we have to look in through this side without changing the eye position, keeping P3 and P4 aligned with each other. Then after completing 4 pins, if you are looking through this side, you can see only P4, right? You can see only P4, yes. You can see only P4. Okay, then this is the path of the light ray. Then we can identify each pin, then straight line P1, P2, then margin of the prism already drawn, right? Then we can draw this line until hits on the point of M, end point, and then it is bending like this and this. Put here, These two pins are extended, then we can identify point of incident and point of emergent, right? Then drawing the middle line, we can identify refracted light ray. Then after making the construction by using the protector, we can measure I1, I2 as well, D, right? Construction take place like that. Okay. Then we have to write here. First one, briefly explain way in which to obtain the incident angle in that incident, right? Placing P1 and P2 two pins, placing two pins of P1 and P2, placing two pins of P1 and P2 align with each other, align with each other, align with each other while looking through the surface of R and Q, while looking through the surface of R and Q, while looking through the surface of R and Q, and place another two pins P3 and P4. Another two pins P3 and P4. Then complete the lines of P1, P2, comma P3, P4. Complete the lines of P1, P2 and P3, P4. And draw the perpendicular line of MN to the point of incident. To the point of incident. Okay, right? Clear. Next one. State the advantage of the gap in between briefly state the advantage of gap between the optical pins P1 and P2 being as large as possible. Yes. If we can put, right, two pins P1, P2 with a considerable gap, a thin line and definite line can be considered as the ray of incident. If they are closing with each other like this, here you are given two pins, right? Here you are given two pins. Here one pin. This is another pin. They are closer to each other, right? And we have another two pins. They are far away, right here. Let's see, Pute. The incident light ray may be deviated right here. Incident light ray may be deviated like this, Pute. Let's see. Incident light ray can have this kind of deviation. Incident light ray coming from this side can have this kind of separation. Here one light ray, here another light ray. දැන් අපි එන light ray එක මොකක්ද කියලා හරියටම දන්නේ නැහැ. මේක focus වෙන්නත් පුළුවන්. මේක focus වෙන්නත් පුළුවන්. අතරමැද්දෙන් එන කෙනෙක් නේ. Incident line can have worst deviation like this. But at here, let's see. If this one is the incident light ray, right here, and right here, let's see. If they are having relatively far away distance, පුතාලට පේනවා ඇති deviation of the incident light ray relatively low. Then thin light beam can be decided with the path of the incident after placing P1 and P2. P1, P2 very thin, but they are having close distance. the incident light ray can have this kind of worst deviation. But here we have only a small deviation. එකනේ light ray එකට විහිදෙන්න තියෙන පරාසය spread of the light ray through the optical region of the observer, right? Optical region of the observer limited when we have this kind of far away distance between the pins, right? If we have here closer to each other, if the pins are closer, then they will have considerable deviation. පැහැදිලි කතන්දරේ, right? It's better to copy this one. පුතේ දැන් අපි මේ ප්‍රශ්නයකට උත්තර ගන්නවාමත්ම නෙමෙයිනේ. මේක පොඩි review එකක් කියන්නේ. හරි? Right. It's better to copy these two first. And can we write down? Next slide. If the pins are far away, if the pins are far away, the deviation of the light rays, if the pins are far away, the deviation of the light rays can have small deviation, body deviation එකක් කියනවා, small deviation. While looking through the observing surface. Right. Roman 3. Next one. Mark the position of P1 and P2 on the line LN. L is here, no? Right. Mark the points P1 and P2 according to the figure we labeled, huh? Right. Briefly write down the experimental step you perform to obtain the emergent ray. Obtaining the emergent ray, right? While looking through the surface of QR, we have already put the points of P3 and P4. No? Now we have to draw the line of P3, P4 to identify the point of emergent. And then N and that point should be straightly connected as to identify ray of refraction. Then considering the normal right here, then we can identify I2, no? Yes. But you are asked to here briefly write down the experimental steps. When they need experimental steps to perform to obtain emergent ray, right? Write down. Looking through the surface of QR. Put another two pins, P3 and P4. Align with P1 and P2. That's enough. Align with P1 and P2. Mark the positions of P3 and P4. Then it was labeled, no? Here, P3 and P4 should be position. Roman 5 completed. Then we have to copy these 2 points, right? Okay, can we check the other part? Mark the angle of deviation D relative to the instance in the same diagram. We labeled, no? Right. The angle of deviation D obtained for I1 in the above experiment are as given in the table. I1 3248 mentioned. The 3267, no? Yes. Angle of incident and deviation angles are mentioned, no? Okay. Can we arrange the graphical arrangement. Right, graph table is mentioned. So we can mark them. First one, I1 30 degree, 30 to 47, 5 minutes, no? 30 to 47, 47 right here. 47, 5 minutes. 47, 5 minutes right here. Nearly like this. Okay, next. 35, 41. 35 degree, it should be 45, right? Next one. $35 to 41, no? 35 to 41. Right, next. 40 degree, 38, 27. 40 degree, 38, 38. 38, 27. Right here. 42, 37. It's 42. 42 degree. Right here, 40 to 45, we have 5 divisions, no? Then 41, 42, 43, 44, 45, done. So they need 42. 42 is right here. 37, 53. 37 right here. 37, 53. Right here, huh? Yes, done. Next one, 44, it's 44 degree angle. 44, we have 37, 30. 37 right here. 30, 30, right. Label in position. 46, 37, 17. 46, 37, 70. Right here. 48, 37, 10. 48, 37, 10. Right here. Next. 50, 30, 37, 13. 50 degree, 37, 30. 52, 37, 20. 52, 37, 20. 57, 38, 6. 57. 57, 38, 6. It's almost 36, right? 38. 62, 39, 29. 62. 62, 39. 39, right here. 67. 45. 25. Right here. No? Then the graphical arrangement we can draw right here. Like this now. Okay, then using that, find the angle of minimum deviation of the prism D. Angle of minimum deviation, we can see until 50 degrees Celsius, 37, 30. 50 degrees Celsius, 37, 13, and 52 degree, then angle of deviation increases, no? Then this region does have minimum deviation. Roughly, we can say the value in between 37.13 and 37.20. This is curved one, as a curved one right here. Then we can write the value, any value in between 37.13 to 37.20. Anyhow, 37 degrees the nearby degree value for the minimum deviation angle. But fair value is 37.13 to 37.20 mid value. That's fair, no? Middle value nikang 37.16. That's fair. Okay. 37.16 is the fair value. Is that clear with that? Right. Take the answer. Right. Roman 2. In order to find the angle of minimum deviation D, are you satisfied with I1 value obtained above? Yes. Satisfied. Reason 37 degree is the nearby minimum deviation, right? 37 degree nearby minimum deviation does have large number of deviations, no? 37, 53 to, which means 42 degrees Celsius to 52 degrees Celsius, large variation of the angle of incident, but deviation angle nearby 37, 53 to 37, 20 minutes, right? Minutes 40ක් ඇතුලේ සෑහෙන ලොකු range එකක් තියෙනවා. That is satisfied. Okay. Write down the final answer. Give your answer. Answer ලියන්න. Minimum deviation nearby angle is minimum deviation, comma, nearby angle is 37 degree. It consists with several values in between 42 degree to 52 degree of the angle of incident. Therefore, given values are fairly distributed. Right. Question C. When this prism is in water, is the value obtained for angle of minimum deviation greater or lesser than the value when the prism is lied in air? It's newly made question. It's a new one, right? Is it like this in the film? Right. When we consider prism is like this, if this is the prism, by keeping in water, right? By keeping in water, like this, it's water here. Then ray of incident, like this. This is the ray of incident. Right here, this is normal light ray. Goes like this, no? Okay. Let's see. Equilateral prism. This is 60. No. This one should be definitely, this angle should be definitely 30 at the minimum deviation angle. Is that clear, brother? This angle definitely 30. Then we have n1 sin I equal n2 sin R. First of all, when we have air, right? When we have air, this one prism, glass prism, here, if it is air, Na, right? This becomes 1, then sin I is given by Ng over N air A into sin R. Its sin R is sin 30. This is definite value. No? Then sin I directly proportional with this one, right? Okay, let it I1. When we have sin I2, which means when the prism is lied in water, here we have Ng over Nw, that's it. And the point is sin 30. Sin 30 would be same, no? It doesn't change. Anyhow, any condition put at the minimum deviation angle, this could be 30, 30, right? Equal values. Then you can see sin I2 directly proportional to Ng over Nw. As Nw greater than N air is 1, this ratio is less value. එහෙනම් පුතාලට පේනවා මෙයාට වඩා මෙයාගේ ratio එක අඩුයි. ඒ කියන්නේ I2 less than I1. මෙහෙම නේද? එතකොට කට ඇරෙන්නේ මේ පැත්තට. ඔය තියෙන්නේ. I2 less than I1. මම පැහැදිලිද කියලා කතා. I2 less than I1. Okay. එහෙනම් කලින්ට වඩා I2 අඩුයි. එහෙනම් මේ පැත්තට එන්නේ ඒ අඩු වැලියු එකමයි. එහෙනම් ලියනවා minimum deviation equal 2i minus a. එහෙනම් I අඩුගේ වැලියු එකකින් තමයි අඩු කරන්න තියෙන්නේ නේ. එහෙනම් dm should be less than dm in air. Less. Underline less. And explain your answer calculation එක දාන්න පැත්තකින් ඒක හැබැයි ඔතෙන්ට ලියලා හරියන්නේ නැහැ. explain කරන්න නේ තියෙන්නේ. Just we have to write the explanation, right? ඔයා කියන්න ඕනේ අහගෙන when the prism is lied in water, corresponding angle of incident decreases compared to the angle of refraction of 30 degree, right? Angle of incident on the prism, angle of incident on the prism which is lied in water, which is lied in water, which is lied in water, bracket I2 less than air, less than air, less than air, less than air, bracket I1, I1. Then, according to dm equal 2i minus a, 2i2 becomes less than 2i1. 2i1. Therefore, new minimum deviation angle less than in air. Question D. When finding the value of the angle of minimum deviation using the above method, state 3 precautions that you can take in order to increase the accuracy of the value. Accuracy of the value, right? Improve the accuracy of the value. Give 3 lines, no? 3 precautions, right? First one, we have to select very thin optical pins. Write down first one. Select very thin optical pins. අර minimum deviation එක මිනිත් ගානකින් එහෙට මෙහෙට වෙන්නේ නේ. ඒ නිසා light ray එක thick වෙන්න බෑ. thin වෙන්න ඕන. First one, use එහෙම නැත්නම් select any kind of presentation very thin optical pins. First one. එකක් හරි නේ. Thin optical pins. First one clear. Second one, considerable gap to be maintained in between the pins. Considerable gap should be obtained. Considerable gap should be obtained in between the pins. දෙකයි. තව එකක්. මොකක්ද ගන්න පුළුවන්? දැන් පුතාලට මේක මතක් වුණා නම් තව එකක් ලියන්න පුළුවන්. මේ බලන්න. According to the values, we can just identify minimum deviation lied in between angle of incident of 50 degree to 52 degree. එහෙනම් ඇයි අපි කරන්නේ නැත්තේ practical එක 52 degree එකට? We have to rearrange the experiment or repeat the experiment. After we have identified these two, but exactly we know the minimum deviation lied in between these two. Then we have to repeat the experiment by selecting 51 degree angle of incident. That is another precaution, right? Yeah. After identifying nearby angle of incident for the minimum deviation angle. For the minimum deviation angle, the experiment should be repeated. The experiment should be repeated. The experiment should be repeated for the angle of incident 51 degree for 51 degree to exactly identify the value of minimum deviation. Value of minimum deviation. Right. Can we check the second experiment? Simple pendulum experiment, right? Okay. Okay. Practical number I, no? Yes. It is used to find the gravitational acceleration by using the graphical arrangement, right? Topic is determination of the gravitational acceleration using the pendulum. Okay. In order to determine this one, right? In order to determine the acceleration due to the gravity using a simple pendulum, then the string connected to the pendulum bob is sent through the cork lid cup and separated down the middle of the cork lid is fixed to the support shown in the diagram given to the right. An indicator pin is fixed to the bottom of the above support that can be directed towards the center of pendulum bob at the equilibrium. Okay, right. Questions. Write down the expression for the periodic time t of the pendulum and define the terms written in it. Equation well known one. No? It's t equal 2 pi, t equal 2 pi root of L over G. Right. T periodic time, L, length of the pendulum in between the fixed point and the center of the pendulum bob. G, gravitational acceleration, Roman 2. Rearrange the above expression so that it's suitable to determine using the graph drawn between the variable and state the two variables. Then here we have to manage t squared equal 4 pi squared L over G. No? Then correct arrangement is t squared equal 4 pi squared over G into L. No? It's y equal mx. This is the graph. Right. Identify the variables. X-axis length, y-axis t squared. Right, clear? Okay, next one. Even though the least count that can be measured by the stopwatch is 1 second, in some stopwatches, the gap of the scale between 1 second is consist in the 5 smaller parts. Yes. What is the least count? Such a stopwatch. 1 seconds divided into 5 smaller parts. No? 5 smaller parts. So like this, no? Right. If this is the scale, you are given 1 second, 0 to 1 second, divided into 5 smaller parts like this, 1, 2, 3, 5, like this. Here 0, 1, 2, 3, 4, 5. Right, from here to here 1 second. Then here 0.2 second, 4 second, 6 second, 8 second, 1 second. So what is the least count of such a stopwatch? Then answer is 0.2 seconds. 0.2 seconds. The time for one oscillation obtained is 1.4 seconds. What is the percentage error of the measurement? Using the fractional error is least count of a measurement value mentioned, no? That's easy. Can be. What is the least count? That's clear, 0.2 seconds. Here we have what is the uncertainty of the time measurement taken by the stopwatch. But the uncertainty error is half of the least count, right? Uncertainty is half of the least count. Half of least count is error uncertainty, right? It's 0.2 seconds divided by 2, it's 0.1 seconds. Done. Time for one oscillation is 1.4. Then least count is 0.1 seconds, no? Here, sorry. Same instrument. 2 divided by 1.4 multiplied by 100, no? Yes. Right. Can we take the answer? It's 100 over 7%. Bedala dandu uttare 100 over 7%. Right. Done. Next one. To obtain the percentage fractional error of the part in the normally unable to accept it. Therefore, in order to maintain the percentage fractional error at very small value of 1%, what should be the minimum time measurement that must be used, bro? what is the minimum time measurement for one person? 1% equal least count 0.2 divided by reading R multiplied by 100. No, this could be the value. Then number of reading. Reading means the time measurement for the reading as the reading should be 20 seconds. No? 20 seconds. Okay. Next one, number 6. Consider 6 values taken for 25 oscillations relevant for the value L is measured 3 times separately for such instance in the tip of the indicator pin place that away is indicated towards the center of gravity of the pendulum bob when it is at the equilibrium state. 3 reasons for this. State the reason for this. Basically, we are taking 3 readings to improve the accuracy, right? To improve the accuracy. Indicator always directed towards the center of gravity of the pendulum bob. Reason that across the center of gravity of the pendulum bob does have largest velocity. As highest velocity occurred by the pendulum, we are taking the indicator to exactly measure the number of oscillations and relevant time. Okay, write down. To take exact time. To take exact time as the pendulum consists with as the pendulum consists with highest velocity at the center of oscillation. At the center of oscillation. Okay. The obtained value for L, T, and T squared are shown in the table given below. Okay. L values mentioned. 25 oscillation time durations are mentioned. Average time also calculated. No. You are asked, show that the percentage error of every measurement taken for the above periodic time is less than 1 second. Every periodic time measurement. අපි ගමු එක එක වෙන. First thing, we can say this one, no? 40 centimeter average time duration is this one, no? 31, 31, 31, 31.4, no? Right. First of all, we can consider first line. Use average value for that. Not one by one separately. Use average value. Okay. So, percentage fractional error of the time measurement. It's 0.2 seconds divided by, you have here 31.4, no? 31.4 multiplied by 100. Here we have 0.63%. And today you can see after that all the measurement. For this line, we have percentage fractional error 0.63%. Round off value 0.6%. And you can see all other measurement here to here, all the measurements greater than 31.4. Then all are having greater, less value than 0.63%. So, lowest time duration consists with the percentage fractional error for 25 identical oscillation is 0.6%. Then it is less than 1%. Then all other having reading, all others are having the reading greater than that time, right? Then take the final answer. Okay. Then say, as the minimum time makes, the percentage fractional error about 0.6% All the other readings indicated, the less value of the percentage fractional error than 1%. Done. Right. The graph of t squared versus L is drawn, no? The copied graph is given. It is a straight line definite graph, right? Calculate the gradient of the graph. Can we check? Gradient of the graph, we can say here, from here to තියෙන values වලටම ගමු අපි ලේසි එතකොට. Like this, no? Then gradient to be considered right here. This angle is theta. Can we check the values? Tan theta equals opposite base 40 minus here 10. 4 minus 1, no? Four minus 1 divided by t square, clear? Here 0.25 meters and 1 meters. 1 minus 0.25 meters. Standard values, SI values mentioned, no? 3 divided by 0.75. Here 1 divided by 0.25, which comes 100 over 25. Tan theta becomes 4, right? Tan theta becomes 4. And tan theta represented 4 pi squared over g, right? Then 4 pi squared over g equate here 4. 4 cancel. G becomes pi squared. Pi squared is 9.84 ms minus 2. Pick the final answer. Using the value obtained the gravitational acceleration. Clear, Buddha? Right. Copy the final answer. Okay. Can we consider part D? Okay. Next. Question D. If the length of the string of the pendulum is L and the radius of the pendulum bob is simple r, then write down the relationship between L and T. If the length of the string of the simple pendulum is L and radius is r, right? You had to write that one, radius is r. The period of the pendulum bob is T. Radius is r and period of the pendulum bob is T. Write down the relationship. Yes, we can say T equal 2 pi root of, today L plus R is the length of the pendulum, right? Divided by G. Okay. Rearrange the above expression in the way of L and the independent of T squared, no? T squared equal 4 pi squared over G into L plus 4 pi squared over G into R, such as y equal mx plus c. 2006 A-level paper එකේදී focus උනේ ඕකනේ. Right, mark කරගන්න. Draw the shape of the graph right here. Calculate the radius of the pendulum bob using the intercept of 4. Intercept of 4, no? Intercept equal 4 pi squared r over g. Gradient of the graph represent 4 pi squared over g, no? Yes. 4 pi squared over g. We wrote this one. අපි මේ value එක කලින් අරගත්තා. 9.84 no? Gradient. Okay, then we can say c divided by gradient tan theta equate these two divided with each other. It's r becomes r, no? Yes, only r we have. C over gradient is this one, right? Then C is 4, tan theta, gradient 9.84. Then R becomes this one, 4 over 9.84 meters. No? This could be the answer. Better than Duttare, right? This is the radius of the pendulum bob.